Welcome to this A to Z series of Pulse Motor Environmental Energy Harvester. In this series, I want to highlight the different components used in this pulse motor system. We want to showcase the circuits that make up this system, why this system is one of the best motor and one of this design that has the capability of harvesting energy from the environment. You can see how difficult it is to stop this flywheel. So this is just a prototype where when the time comes, you have a massive flywheel that will give us what we're actually looking for. Now this is the starter coil. In here is the Hall effect, and another here is another coil, the starter. This one now is used as the output, while this is the main triggering unit. Here is the MOSFET and the Hall effect. So we can view this from this setup, motor circuit. Now we have all south pole magnets, the starter coil, the Hall effect. Now, if you watch from this flywheel, you see that the point, this center point, that is the main point of triggering this Hall effect, is not the same alignment with your starter coil. It is at the edge of this starter that is the main point of the alignment between the Hall effect and the magnet. So when this magnet approaches this hot spot, you now see that it is actually leaving, the magnet is actually leaving the edge, is at the edge of the starter. That means once this thing is on and this man is energized, you have the peak repulsive force at this point, so that when this is aligned, the force of pushing it out of this starter will be maximum. This is the maximum point, the peak of repulsion. Now, if you want to go with the attractive force, almost the same thing, but here you have to move a little bit far from this point so that the force, now the distance, will be enough to draw the system. So for this is how you align this, the starter, the Hall effect, and the magnet. That is what we did here. This is your magnet, here is your Hall effect. If you check, so then the next is the whole circuit. The complete circuit says your Hall effect 3144. That's the Hall effect we use here. Then it has three terminals. The three terminals, the first terminal you see from where the numbers are is the positive. The middle number, the middle leg is the negative, while this final one is the output terminal. Now this is our 24 volts battery, represented by this battery here. So the 24 volts, the positive, the first leg, which is the positive, goes to the battery through 1K resistor. You have a 1K resistor there, positive through the battery with a 1K resistor. The negative, which is the center terminal, goes to the negative of the battery, while the output goes to the gate through a 1K resistor of the MOSFET. Now, the MOSFET we use in this circuit is a P-channel MOSFET 9540 MOSFET. Now, this is the MOSFET, the gate, the source, and the drain. Now, the source is connected to the positive since it is a P-channel MOSFET. Positive, positive, negative, positive. So the negative charge coming out from this Hall effect is fed to the gate of this MOSFET. Then the drain now goes to the output, one of the coil of this starter. Then the negative will now be connected direct to the negative. And before you do this, you have to test your starter coil. The coil, you must test the terminals and know when you connect the negative, the positive here, and the negative, you check the effect of that on the magnet, know whether it is repelling or attracting. If it is not well positioned, you either turn the coils. Use this. When you alternate it, the reverse becomes the case. Then it will either repel or attract. But in this case, we are going for the repulsive force. That means you have to position it first of all with your battery to know if here is the positive and here is the negative. Will that terminal repel the magnet? If yes, then you now switch to this. Here now is the positive side, while this is the negative going from the coil through the battery connected with the negative of the Hall effect. Now this Hall effect must come with a very long wire so that you can adjust the position, because if you watch our second video we did on this series, you will find out how we change the position in order to get the maximum speed at a minimal input power. So those are the things you have to put into consideration. So if you must follow this step by step, you will have to watch our first video, the second on this series, while this one is the third, the circuit diagram. Now this is your starter. Then you now connect a rectifying system. This rectifier must come with a very fast diode, a diode that has the capability of tracking this high voltage spark. Then this should be connected through a 1000 UF 100 volts capacitor. Then when you rectify it, this becomes the negative and the positive. You can now feed this to your battery. Lead acid battery is the best for this setup. Then this is your MOSFET. The first leg is the gate, the center is the drain, while the other one is the source. So this is still the MOSFET we use. Here we use the IRF. Go down a bit. IRF 9540. That's the MOSFET used in this setup. IRF 9540. So this is now the output. Goes straight to the battery. Then in here we use the supercapacitors to collect the charge. So Here is the circuit, all you need to know about this system. So if no matter how you want to do it, this is the basic system for you to design this. So this is it. So all you need in this build up. So let's go back. So that is how it is made. Then you will see. So from our first video, you know how we couple this flywheel and why this is moving like this. So you have to go back to the first video to get all you need to know about the assembling. For this tutorial, it's all about the circuit diagram and the configuration. So from JF Green Energy Concept, our message here is make sure you follow this series for everything you want to know about this basic concept of pulse motor free energy generating system, because after this series we are going into the main free energy harvesting. So make sure you subscribe and follow us in this series. Thank you.